Hi, I'm taking Paul McWhorter's AI for Everyone lessons, and this week we're on gesture recognition. And our homework for this week was to normalize our data so that it didn't matter how far away from the camera our hand was. Um, so I got my homework done. I figured I'd show you how I did it. But first, I started talking last week about my quest to uh, just harvest good data from our hands array. So last week I showed you how I went down from 400 distances to just pulling out 36 distances. But even that has some noise, some zeros, and some repeated data in it. So I actually uh, have it down to 15 points of good data where you're just comparing individual points and you're not duplicating and you're not getting zero readings or anything on any of them. So let's get to the code and I can show you how I'm doing it here. So in the past, last week, we were iterating over a nested loop to get all our points. Decided to do it a little different this time. So I got a tuple of tuples here. So we got the pairs that we're going to just get our data from. And like I said, there's no repeats here, so that's good. And I added in one point that we needed is 0 to 17. So that's from the palm to the little finger first knuckle, and I thought that was a good number to do our scaling factor on. So that's what so we got actually 15, 16 points in there now. So, and then our beings we're turning, instead of being a two-dimensional array, we're turning into a one-dimensional array. For that part of it is just 16 points in there. And then I'm making 10 of those as the second dimension, one for our unknown and up to 9 known that we can store all in that array. So that's the way that worked. I knew we were going to have our current heirs, a list of our current heirs. So I created a list by doing this to create a list of 10 entries of 10,000. I wanted a high number here because we're looking for the lowest number. So I didn't want a bunch of zeros in there. They'd be false readings. So I didn't get that. And then, we have our tolerance threshold here of whether we consider it a good read or not. So we got that there. Like I said, for the joint distances, we went from a nested array down to just a single array based on our key distance list up there, tuples. And we're just doing the math here, the same square root math to get that list of distances. Like I said, there's a function that we can call. Our air function is the big difference for this week, is because we just wanted to get our scaling factor involved in that. So, scaling factor, I knew it was be an inverse proportion to the size. So it would be something over the distance. So the way I did it, before our last week, our thing stopped here, but now we're multiplying by 100 over our palm to first knuckle distance. That's our 0 to 15 is our number 15 data point is that. So that gives us, the reason I went with 100 over that is that if you notice here in our numbers that our distance at a normal distance on the screen was right around 100. So we didn't want to change our data values too much. They seem to be working for us. So by doing this, we put 100. So if we're far away from the screen, we're going to have 100 over maybe 80. So it's going to be less than 1. So we're multiplying by less than 1 because all the values are are small. And but if this is big, then it's going to be, no, I'm wrong on that. It's 100 over 80 is 1.2. So it's going to increase the size of these numbers. I misspoke. And but like if we're close to the screen and this number is 120, then it's going to be 100 over 120, which would be less than 1. So these numbers would be smaller. So they're actually scaling all to the same. So we did that on both sides of our subtraction here just to get good numbers. I'm not sure how Paul's going to do it, but this seemed like a good way to get that scaling factor to me. Just add a couple extra calculations there. So had to do a little extra work. Like I said, I'm still using my PySimple GUI program to make it look pretty. So had to add a few things to so we could save our values. We were just displaying them and not really displaying them to the GUI and not really doing any saving of them with it. So now we're saving them, and like I say, this first part we're just doing pretty much the same thing. The changes come down here where we're actually when we find our error, we're saving it to a variable rather than just printing it on the screen. We're still printing it on the screen here and in this update method, but we're also saving it as one of those 10 things there. And then we're basically testing the if the threshold, if our number is bigger than the threshold. So I know Paul doesn't like these fancy functions, but this was a pretty cool function here. So we have our list of 9 current E's up there. And I said, what's a nice way to do that? So I actually looked it up, and there's a Python way of doing it, and it seems to be pretty accepted. So just to get the smallest one, you just do min of that list, and it'll return that value, whichever the smallest one is. But then I wanted to have that correspond with the index number to our text, our input text, like peace sign or fist or whatever. So I needed to actually know what index it was. So you can also grab the index by doing that. You this little bit of code here actually returns the index of that smallest number. So this is how you get the smallest number in a list, and this is how you get the index of the smallest number in a list. I certainly could do that longhand, take about 5 or 6 lines of code. I'm going to take the easy way out and just do it in one line. I know how it works, and I just say, okay, let's do it this way. So anyhow, we got that. So we're getting the value, and then we're getting the index of it, and we're using that index to grab that text that's associated with that gesture, and then we're printing it out. But if we don't, if it doesn't meet, if none of them meet the minimum threshold, then we're just printing unknown. So, and then we're just doing our bookkeeping here, putting our frames per second up and closing it when we hit quit or closing the screen. And that's about it. So let's see how it's working up here. All right. So I got test up there. I probably should have put unknown up there as the first one, but that's just the default text that you start out with. So we'll just do a couple here. So I'm going to do fist. And I'm going to do peace sign. If I can spell. And we'll do 5 fingers. All right, so that's the 3 we're going to get. And then, like I said, we just click here to train. So we're going to start out with the fist. All right, so see how our scaling factor worked. We're going to go closer and away. So it is a lot better with the scaling factor in there. So now we're going to go with our peace sign and we'll go on that. Same way. So like I said, I chose, after looking at all these, I chose 400 as the thing, as a point. Okay, so we got 5 fingers now, so we're going to go on that. So our scaling factor, until you go off the screen, if you go off the screen, all bets are off. All bets are off once it's off the screen. But it picks up 5 fingers, peace sign, and fist. Peace sign, 5 fingers, peace sign, fist. All right, well, that's all I got this week. Code was nice and easy. I think those 15 points of data plus the 1 for the scaling factor, I think that's all I'm going to need in my program. So happy to see what Paul comes up with next week to show us how he did it. But I kind of like my way.